Good morning, everyone. This is the session 24 of NEET Physics, and the chapter is rotational motion. And I have taken this question which was asked in the NEET examination in 2016. So I have taken this question because I found that many of the students are not able to solve this type of question. Um, uh, Maybe because they might be having some difficulty in understanding the basic concepts. So, uh, here the question is, there is a disk of radius r and mass m, and a circular hole of diameter r is cut, whose rim passes through the center. So, the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center is. So we have been given four options, so we have to find the correct one. So I will be just explaining this question with the help of this diagram. Now here I have made this circular disc. The radius of this disc is r. The radius of this disc is r. And a circular hole of diameter r is cut in such a way that its rim passes to the center. That is, a hole is cut from this disc in such a way that its rim passes through the center. Like this. So this is the hole which I have made with the now this is the hole which has been cut from this disc, and its rim is passing through the center. Now this is the center. I am just denoting the center by O. So in the question it is given that the circular hole of diameter r. So the diameter of this hole, or you can say the disc which has been cut from this disc, that is from the bigger disc. So the diameter of this hole is r. So we can say that the radius is equal to r by 2. The diameter of this hole, or you can say the disc, which has been cut from this bigger disc, is r. So the radius of this hole is equal to r by 2. Now we have to find the moment of inertia of the remaining part of the disc. That is, we have to find the moment of inertia of this part, the part which I am just highlighting with the help of these straight lines. So this is the remaining part, and we have to find the moment of inertia of this part. So now the mass of this whole disc is given as mass of the whole disc is equal to m, capital M, and the radius of this whole disc is r. Now in order to find the moment of inertia, first thing is that the mass of this whole disc is given as m. Now we have to find the mass of the disc which has been cut, having a radius equal to r by 2. So you know that the mass is equal to density into volume. So the density of this cut piece, that is the cut disc, and this whole disc is the same. So or we can say that the mass is equal to density. Now volume is what? The volume of the disc is equal to pi r square h, where r is the radius, so pi r square h, where h is the, you can say, the thickness of the disc. So here we can see that that is the mass is directly proportional to r square, because the thickness of the disc of this cut disc and this whole disc is the same, and the density is the same for both the discs. So the mass is directly proportional to r square. Or we can say that if the mass of the bigger disc, the whole disc, is m, then the mass of this cut disc, the mass of the cut disc is, let us say, I am just denoting the mass of the bigger disc or the whole disc is as mb, mass of the bigger disc, and the mass of the cut disc, I am writing it here as cut. So this will be equal to, is proportional to r square, that is, it will be proportional to what is the radius of this bigger disc, that is equal to, it is given as r, so it will be equal to r square divided by the radius of the smaller one is r by 2, so that this will become equal to r by 2 whole square. So it implies that the mass of the cut disc is equal to, this will be equal to, this will go here and this, so this will be equal to, or we can write it this as r square and r square will get cancelled and this will be equal to 4. Okay, so the mass of the cut disc is equal to the mass of the whole disc, which is equal to m divided by 4. Okay, so the mass of this disc which has been cut and whose rim is passing to the center, having a radius of r by 2, is equal to m by 4. Okay, so here I will be writing that the mass of the cut disc is, I am denoting it by m cut, is equal to m by 4. Now the moment of inertia of this whole disc is equal to the moment of inertia of this remaining portion and the plus the moment of inertia of this cut disc. That is, moment of inertia of the whole disc is equal to the moment of inertia of the remaining disc plus the moment of inertia of this cut disc. So this is the formula which we will be using in order to find the moment of inertia of this cut, or you can say the remaining disc. Okay, so I will be writing this equation here, that is I whole, that is the moment of inertia of the whole disc, is equal to I remaining, that is the moment of inertia of the remaining part, plus the moment of inertia of the cut disc. So this is the equation which I will be using in order to solve this equation, solve this problem. So the moment of inertia of this whole disc, we know that the moment of inertia, now we have we have to find the moment of inertia of this remaining disc about a perpendicular axis passing through the center. That is, we have to find the moment of inertia about this axis. This is the axis which is passing through this center. So I am just denoting this axis, let us say, as y dash. Okay. So the moment of inertia of this whole disc about this axis is equal to mr square by 2. Now this is the standard formula which is available in the books. So the moment of inertia of this whole disc is equal to mr square by 2. Now the moment of inertia of the this, we have to find the moment of inertia of this remaining part, that is that part which is means the remaining part after this disc is cut, having a radius of r by 2. So the I remaining, that is the moment of inertia of the remaining part, is equal to the moment of inertia of the whole disk, which is equal to mr square by 2, minus the moment of inertia of the cut disk. So now here I have to find the moment of inertia of this cut disk about this axis, that is y dash. So in order to find the moment of inertia of this cut disk, we will be using the parallel axis theorem. We will be using the parallel axis theorem. Now, what is the parallel axis theorem? The parallel axis theorem says that the moment of inertia of any object is equal to the moment of inertia about an axis which is passing through the center of mass. Now, in this case, if you just see this disk, so the moment of inertia of this disk about an axis which is passing through the center of mass. Now, this is the center of mass is what? The center of mass is that point at which all the mass of that particular object is concentrated. So if the mass is uniformly distributed, then this center of mass will pass through this center. That is the center of mass will be the center of this disk. So the axis which is passing to the center of mass, I am just denoting it by, let us say, by A dash. Okay. Now the parallel axis theorem says that the moment of inertia of this disk about an axis is given by, that is the moment of inertia I is given by ICM plus md square, where ICM is the moment of inertia about an axis which is passing to the center of mass, plus the md is what? D is the distance between the axis passing to the center of mass and the axis. In this case, D will be equal to the distance between the axis passing to the center of mass and the axis, that is y dash. So this is the perpendicular distance between the axis passing to the center of mass and the axis about which we have to find the center of mass, about which we have to find the moment of inertia. So we have to find the moment of inertia about the axis y dash. So in this case, the moment of inertia of this disk will be equal to the moment of inertia about an axis passing to the center of mass, which is equal to ICM, and ICM will be equal to, this is equal to m I will write it here now. That is I will be equal to, now ICM, the moment of inertia of this circular disk will be equal to half m r square. Now half m was equal to m by 4 and r is the radius, so r radius is equal to r by 2 whole square. So this is the moment of inertia of this disk about an axis passing through the center of mass, and we have to find the moment of inertia about this y dash axis. So in this case, the moment of the inertia of this circular disk will be equal to ICM, which is equal to half into m by 4 into r by 2 whole square, plus md square, where m is the mass of this circular disc, and d is the distance between the axis which is passing to the center of mass and the axis about which we have to find the moment of inertia. So the distance between these two axes is d, and d will be equal to what? D will be equal to r by 2. This is the distance. Okay, so this will be equal to r by 2, like this. Okay, so I will be writing it here as m, and that is equal to m by 4 d square. And what is d? D is equal to r by 2. So I will be writing it here as r by 2 whole square. So the moment of inertia of this cut disc about this y dash axis will be equal to this value. So now we have to find the value of I, that is the this moment of inertia of this cut disc about this axis y dash. So this is equal to, this will be equal to how much? That is equal to mr square divided by 4 so 1 by mr square by 32 plus mr square divided by 16. Okay, so this is equal to, if I take the LCM as 32, then this will be equal to mr square plus 2, that is equal to 2 mr square. This is equal to 3 mr square divided by 32. So the moment of inertia of this cut disc is equal to 3 mr square divided by 32. Now we have to simplify the value of this remaining part of the disc. So I will write the value of this moment, that is I cut disc, is the value of this the moment of inertia was equal to 3 mr square divided by 32. So the moment of inertia of the remaining part will be equal to I, that is the moment of inertia of this entire disc, which was equal to mr square divided by 2 minus the moment of inertia of this cut disc, which is equal to 3 mr square divided by 32. So this is equal to, if I take the LCM as 32, then this will be equal to 16 mr square minus 3 mr square. So this is equal to 13 mr square divided by 32. So the moment of inertia of this remaining part of the disc is equal to 13 mr square divided by 32. So the correct answer here is the option A. This is the correct option, that is A. So in this question, the most important thing which we have to understand is that first thing you have to calculate the mass of this disc which has been cut, and the mass of the disc is directly proportional to r square. That was, mass was directly proportional to r square. So I have found the mass of this cut disc, which was equal to m by 4. First thing. Second thing, we have to use the theorem of parallel axis, and the theorem of parallel axis says that the moment of inertia of an object is equal to the moment of inertia of that object about an axis passing through the center of mass plus the moment of inertia of an object about about any axis is equal to the moment of inertia of that object about an axis passing to the center of mass, and the product of, that is, I was equal to ICM plus md square, where m is the mass of this disk and d is the distance between the axis which is passing to the center of mass and the axis about which we have to find the moment of inertia. So in this case, the d was this d. This is the distance d. So this was equal to r by 2 because the radius of this cut disk was equal to is equal to r by 2. So d was equal to r by 2. So and m was equal to m by 4. So using this theorem, I had calculated the moment of inertia of this disk which was cut from this whole disk. So after calculating the moment of inertia of this cut disk, I was able to find the moment of inertia of the remaining part, which is equal to 13m, because 13m r square divided by 32. And the third most important thing is that for any object, the moment of inertia of any object is equal to the remaining part of that, of the moment of inertia of the remaining part of that object if some part is cut from it, plus the moment of inertia of that cut part. So that is the, here you can see here we have just cut a disk from this whole disk having a radius equal to r by 2. So the moment of inertia of this whole disk will be equal to the moment of inertia of this remaining part plus the moment of inertia of this cut disk. So using this equation, we have been able to find the moment of inertia of the remaining part, which is equal to 13 mr square divided by 32, and the correct option is A. So in the next session, I will be continuing with the same chapter, and I hope you have understood the solution of this this question. In case of any doubt, you can definitely contact me on my mobile number, which is 9911079547. And so thank you very much once again for joining this session, and have a nice day. Bye.